Let me know when you're seeing the countdown.
We're on.
Hi everyone, welcome to the Chamfering Basics live stream. We're just going to leave a few minutes just for a few more people to join in. Hi everyone, welcome. So just a quick introduction for those of you that don't know myself or Paolo. We're from the process specialist team for Fusion 360. We do normally specialise in the manufacture side of things, but we've both got quite a good grounding in the design as well. So I'm based out of the Birmingham office in the UK, so we've got quite a big tech centre there with quite a few CNC machine tools as well as other bits of kit. And Paolo used to work in the office with us but has now transferred back home as a home worker over in Italy. So yeah, we'll just let a few more people join on and then we'll get started. So we've got the chat today. Please feel free to submit any questions in the chat. We'll do our best to answer them either live or Paolo will be actually the one managing the chat today, so he'll try and answer them via the chat if not. And again, we're all on the forums, so if anyone doesn't know of the forum, if you've been living under a rock, please feel free to go to the Fusion forums. And it's not only other customers on there, the majority of our team are quite active on the forums as well to try and answer as many questions as we can.
Yeah. So, like Richard said, if you want to type in any questions you may have, I'll try my best to answer them live. If we don't make it on time, or maybe we don't know the answer to the specific question, we'll make sure to get back to you through the comments.
So yeah, cool. Nearly there, and we'll just get cracking and go into this. So we'll hopefully just show a rough overview of some of the chamfering ways we can do things, and a lot of things really where I've struggled actually on the machine and problems I've had and how I've got around them. So yes, and hopefully some tips and tricks that we can go through on there. Again, please let us know if there's anything on the going wrong on the videos. Put it in the chat and we'll try and sort it out. But yeah, okay, let's get started into everything then. So this is just the rough part I've made up for this demo. We've got a couple of different things. We've got modelled chamfers and we've got chamfers that aren't modelled. We've got areas here where it's going to be quite difficult to chamfer there, with that really small gap we've got going on. But I'll show you some tips we can do to do that. But the very first thing I do want to quickly have a look at is tools themselves, and what do they do and how do they work. So what we've got here is different zones on a chamfer tool, and I like to think of it as at the very tip you've got really a no-go zone. It's really slow, you've got a slow surface speed, and also the tips are very weak. A lot of these examples I'm going to be looking at today are going to be referring to sort of solid carbide chamfering tools, so with a perfect tip ground on the end. Yes, you can do this with inserted chamfer tools and different, but we're just going to try and focus on the one example for now. So you've got that no-go zone at the very bottom. You've then got really a good portion of that chamfer tool working up the flute. And then at the very top, you've got another, what I like to think of as like a no-go zone. You don't want to be at the very top of that flute because the potential are you'll actually fold a burr up onto the part rather than cutting it. And of course, with that green portion, the higher up you are, the actual better you're going to get. So you see my sweet spot that I like to think of is actually right between sort of the top of the green and then the bottom of the upper red portion there. And the reason behind this, if we just look at the speeds diagram, is On a 45-degree tool like this, the surface speed really changes. So if you're not quite sure what surface speed means, imagine the tool's rotating at 5,000 RPM. How fast is that position of the tool actually going to come into contact and cut the part? So this is not how fast your machine is traversing. This is how fast the actual tool is, but it's how it's working as well. So we look at 9, you're at the diameter 9 of that tool, you're at 141 meters a minute. We go down to something like at the half a mil point, you're 7.8 meters a minute. So that's a huge difference in surface speed. So what you might think there is you need to actually increase the speed of your spindle to get a better chamfer and a better surface finish, but actually just adjusting where you cut along that flute can have a huge difference. And then you see the different circles where, imagine that's like racers on a racetrack. You all start staggered as you come back. And then, because the people on the outer actually travel further than the ones on the inner. So it's exactly the same principle here. So that's what we look at there on that tool. And we need to sort of really know where our sweet spot is on our flutes to get the best surface speed we can. So some of the settings that are actually then inside of Fusion. Chamfer width is quite an easy one. How big a chamfer do you want? Everything we will be covering today is 45-degree chamfers. It does, of course, work with others, but let's keep it nice and easy for the maths for now. Tip offset. This is a huge one for us. So this is how far down from the top of that chamfer is the tip of our tool. And that's how we adjust the chamfer to get into that little sweet spot of the flute. That's the big one. And then we've got chamfer clearance. This is a really cool trick. I mean, we'll see this a lot more later. I think it's one of the sort of the most understated functions in Fusion. It's saved me smashing a lot of tools in the past. And it's something where you'd normally have to do a lot of calculations on this. But with Fusion, you can actually let the algorithm in the background do all the work for you. And you can just have a look at the results and see if it's what you're after or not. So yes, that's hopefully what we're going to be looking at today. How to get the right chamfer and some tips and tricks in doing so. So what we've got 2 chamfers here on these 2 bosses, nice and easy to start with. So I'm going to go down 2D chamfer. First thing I need to do, of course, is select my tool. That's tend to be what I always start with. I'm going to be using a 45-degree chamfer tool, 12mm diameter for this. So actually, if we just have a quick look at how I've defined this, we can start to have a look in here. We can go on that. So let's go on to the geometry actually first, I suppose. We're going to select just that one contour for now. We're going to have a look at our passes tab. And I just want a 1mm chamfer. Now I'll go back to my tip offset. I'm going to leave that at 1mm for now. And then we're going to simulate, see what it's like. And then we're going to adjust it to get back into that sweet spot. And then we've got the chamfer clearance. That's not going to make any difference on here. We've got loads of space around the part. We're not going to be getting anywhere near any sidewalls. Again, not talking about feeds and speeds at the moment. We're just having a look at the toolpath and setting that up. So there we go. Let's just simulate this. And let's play that chamfer on there. So again, get a nice chamfer. Little trick here that I do. If you're ever chamfering the model, I tend to turn the model off just so you can really see what's happening. Otherwise, you don't really get a good idea of what's going on because the model's in the background there. So we can see here the point we are on the tip. We are really quite close to that tip. So from that diagram we saw earlier, we're going to be effectively on that bad point here where we've got a slow surface speed and the weak portion of the tip. But what we're going to have to do is move that tool down using our tip offset. So let's jump out the simulation mode again, turn my model back on just so things look correct. Then I'm just going to edit my chamfer toolpath. And in my tip offset here, I'm going to put 3mm in. I'll talk about why I chose 3mm once we see the effect it's going to give. And then let's just simulate this now. So again, turn my model off, run that toolpath again, and I'm just going to pause it when it gets around the view. So again, we can see now we've managed to get much higher up. I could probably go a little bit higher if I really wanted to. We've got much higher up on that flute. You know, we could have probably doubled or tripled our surface speed in that small move there. So these little tips and tricks really do make a big difference when you're cutting using chamfer tools, and it's definitely worth spending the time to do a couple of test runs on your machine. So if you tend to use a 12 or a 6mm, just get to know how the tool wants to be used, the speeds and feeds, and then you can apply that as you go. Let's just close that again now. So I didn't just guess 3mm. I did a little bit of a calculation in my head, but I don't want to do that in my head every time I actually do the chamfer. So this might be new for some of you, but you can actually do expressions and calculations in all these boxes. So I'm going to do edit expression. That was just right click, edit expression there. And I'm going to choose my tool flute length. So that's going to be 6mm, because it's a 6mm flute. I then want to sort of minus my width, so my chamfer width. And then I want an extra millimetre of clearance on the top of that tool as well. So let's go 1.5 actually. Let's go 1.5mm. So that's going to be expression in there now. So it's basically told me that my tip offset is now 3.5. So that's going to leave 1.5mm above the tool where I'm not in that zone where I'm risking a burr because I'm too high up. So let's just play that. Again, turn my model off. Let that tool come all the way around. And you can see now I'm really getting a good portion there. Now the brilliant thing about this expression is that that's going to be there every time I want to do a chamfer. So what I can do now is right click and edit. If I want to, I can save that as default. So I can make that as a default. So now that expression is saved as a default. Every time I come to do some more chamfering, it's going to be there. So that's a little bit about how we've machined that one. Let's quickly do that again. And let's go 2D chamfer. Let's pick that contour. It's remembered my tool because I've just used it. And again, we've got this perfect scenario here where it's known that chamfer width. So if I just change that chamfer width to 1.5, you see it's just changed to 3. You get the idea. If I change that to a 2mm chamfer, it's changed my tip offset. So that's a really good default to have in place. It's one that I personally have, but you do need to know where that's not going to work. So there are a couple of scenarios where you're going to need to override that default that's in there. Let's just have a quick look, make sure that everything's working as it should be. Turn the model off, hit play, turn the speed up a little bit on there. There we go. And that's putting a really nice big chamfer on there for me. But again, one thing that I just really want to point out in here, if we just reverse a little bit as we go up, you'll see here that we've got a red plunge move here. So unfortunately, that's going to be a really slow feed rate. That's because we tend to prefer safety over speed in Fusion. But what we could do is actually on here, we can look at that toolpath I've got here. I want to edit that, go over to my heights, feed height, and actually disable that. So it's going to go right down straight away at the rapid speed and not do that really slow move. So let's simulate again. And I'm just going to press play. Let's turn that model off again. So chamfering there, I'm just going to slow it down now. So hopefully you can now see, there we go. So that red move has now turned into a yellow rapid move. Again, we prefer safety over speed any day of the week, but I know personally that I can disable that plunge move on there and just rapid straight down and move across. So hopefully this is just showing some little tips and tricks that you can do. Again, if you really want to be brave, you can set that as your default, but I personally prefer to leave it to do the plunge on the slower speed, and then if I remember, I'll turn it off. If I forget, I go slow. If you do the opposite way around and you forget, you crash the tool. So I prefer to, again, always safety over speed in my opinion. So what we've got now is we've got a model chamfer. So again, we had a non-modeled chamfer on here, and we've got a modeled one here. So I'm going to go 2D chamfer, choose my geometry. Now this is the key one. I'm choosing the top contour on this. So when the chamfer's modelled, you choose that top contour. But one thing I need to bear in mind now actually is this that I chose here might not be correct. But I'm just going to press OK, and I'm just going to run through and show you what I get. I'm going to leave a 1mm chamfering. Just going to leave that tip offset in, chamfer clearance, just leave all that as it was, and I want to see what we get. Again, this is a lot of simulation in this. So I'm just going to run through those two toolpaths. I'm just going to go to this next one here now. So you might notice actually that is a huge chamfer in comparison to that one. But I set 1 mil, so why hasn't it worked? And it's all to do with if it's modelled on the part, what you've effectively got, you've got a 1 mil chamfer that's been modelled, and then you've got an additional 1 mil chamfer that you've programmed into there now. So I need to remove that and set it at 0. Now remember I said earlier about watching out, that default you've just put in could catch you out occasionally, and this is an occasion where it will. But I'm going to leave that at 4.5 for now and just show what happens. So again, just to quickly go over that in case you missed it, if the chamfer is modelled, you choose the top contour, and then you now go passes, chamfer width 0. Okay, cool, there we go, cancel. I'm just going to simulate that 1 and turn that model off. And you can see that it's doing the correct 1 mil chamfer, but it's a little bit too high on that tool for my liking. But that's because the default on there for the calculation I set is no longer true. Because of course, if I look back at my expression, I had the chamfer width in there. The chamfer width doesn't now exist, it's 0 because the part was modelled. So I need to make a manual judgment on this. So I'll probably go back and set that manually at something like 3.5. So yes, that default is brilliant and it works for non-modelled chamfers, and you know, if you want to, you can set it up for modelled ones too. But it's just bear in mind, if you start going around setting yourself new defaults, you've got to know the cases where that will work and where it won't work. So just bear that in mind. I hold no responsibility for any broken chamfer tools. So there we go on there. Okay, cool. So we get on there. Again, if you've got any questions, I'm a bit famous for being able to talk all day long without stopping. So please just chuck your questions in the chat. Paolo will interrupt me, as he does most days, and let me know what's going on there. I see we've got a guest of Alon watching us, making sure we're all doing all right on here, making sure we're 6 inches apart from each other anymore. If you could convert that 6 inches into metric, please, Al. This is the British and the European live stream, so we have metric only, please. So right, we've got this chamfer clearance that we want to talk about here now. So this is a really cool tool that makes sure you hopefully won't end up breaking any chamfer tools on sidewalls. So what we've got here is we can see that the chamfer width is 1 and the tip offset is 1. And we're going to get a collision on that sidewall. But I still want a 1 mil chamfer. So I'm now going to put my tip offset as 3. So what it's done is it's brought that tool back down the flute a little bit more, and brought the shank of the tool away from that wall. So that's just little tips here. You've got to look at this and you've got to try and balance up how things are going on there, really. Okay, so what does that look like in practice? So what we've got on here, we're going to do a 2D chamfer, and the first thing we're going to look at is this contour around here. I'm just going to do a 2D and go contour selection. But I definitely don't want to do that contour, I just want to go around here. So a little tip for you all. If you hold down Control and Alt, you actually select an open contour. And what you can do then is you actually start to go into there and you can edit the way this is selected. So let me just try that again. So I'm going to choose the contour selection, go on there. I think I've got a weird bit of a surface on there. Let's go for this one instead. So let's go 2D chamfer. I'm going to choose that one. So you can see I'm really quite close to the edge over here. I'm actually moving around now and coming back to there. So that's what we've got. I'm going to go on to the passes. Chamfer width again, 1. I've got my automatic expression there that's calculated a really nice position for me. I'm just going to hit OK and see what happens, and we'll talk about the result we see here. So we've got a broken chamfer there. And what it's done effectively is it's done what it can do respecting the parameters that we've entered. So let's just simulate this and see what's going to happen slowly. So we're going to cut what we can there. We're going to then come over, just turn that model off, and then we're going to cut the other side. So there we go. So what Fusion's basically done is gone, you've given me a set of parameters, you've given me a contour, and I'm going to try and machine as much as that as I can, as safely as I can. So I want to talk about two aspects of this toolpath. The first one is I want just to see how close we've got to that wall at the end there. So bear in mind that my contour selection went right up to this edge here. Of course, we know there's no way that I can get exactly there because I'd end up hitting my shank of my tool against the side. So what Fusion's done is respected that 1.2mm chamfer clearance and has kept 1.2mm from the side wall to the shank of the tool. So that's what we've got here. Now the second aspect of this toolpath is this big gap in the middle effectively that I've got. So let's just model it up. And again, that's doing exactly the same thing. So if I just leave that tool just there, and we have a look, it's saying I cannot get any closer with what I've got here. So, I mean, I've heard people call this like the magic chamfer tool before, but I do think it really is one of the most underrated functions that we've got at the moment. It's so clever, and it saved my skin on many occasions. So I'm going to go to my passes, and I'm going to be brave. I'm going to drop this down to 0.5mm. I'm just going to hit OK and see what result I get. So it's got a little bit closer. You know, I've got a bit closer over here, but I've still got this big gap in the middle. So let's try and go a little bit braver even still, and let's go to like 0.2, see what we get. So you basically see that this is just a big balancing act really. And again, I've got a little bit closer there, I've got a little bit closer here. Let's simulate it and have a look how much closer I've really got. Again, let's just, I was meant to stop it then, not replay. There we go, models. So I'm getting a little bit closer. Every time I make a change, it's getting a little bit closer over here. But I've still got this big gap in the middle. And that's because I'm going to start to have to make sacrifices now on my tip offset. So again, I said about earlier, we had that sweet spot up here. We had the no-go zone at the bottom of the tool, the no-go zone at the top, and we're really going to have to start pushing this tool now down to here and get that top portion. So let's come back in. Let's just edit this. And what we've got now here, and I'll just go to top tip offset. So, I mean, how far can I go on this? So, if I'm honest, I can, if we're not looking at the problem with the burrs, we can go straight to 5mm. So what does that look like? It's got the full contour selected there. So let's simulate this. You know, in theory, this will work, but in practice, everyone knows there's no way that's going to give you a good chamfer with that being right there. But you know, the whole point of that is it's come round, and we've got minimal clearance now over here. So what I'm going to have to do is do this balancing act, and I'm going to have to look at how high can I get my tool just to give it a bit more clearance while still cutting this whole chamfer round. So let's edit this, and let's go for 4.5. Let's see what 4.5 looks like. Nope, broken. And it, you know, you can start looking at it. I could measure that distance and I could start calculating it out. But if I'm honest, I'm quite lazy, so I just tend to use the calculation speeds to my advantage, and I'll just start playing with these numbers, and I'll just see at what point does it break up. I mean, so 4.5 it broke, 4.7. Let's have a look at 4.6. It's broken up again. Okay, right. So let's go back to 4.7. Again, my mathematics. There we go. It fails to express 4.6 mm, 4.7. I mean, why isn't it clever enough to realise that I did a mistake there? 4.7. So again, it's realised what I've got going on here now, and it's got us close to there. Let's simulate this and see what it really looks like. So hopefully you're looking at the difference between balancing tip offset and chamfer clearance. They both are two different things, but they do work together. You know, you do need a bit of a balance of two. So again, I mean, That's going to work. It's not going to be the best. It's getting a bit too close really up to the area where we're going to get burrs, but I'm confident for just this small part, it's going to be good and it's going to work for me. We can also see how close we've got to this edge here. Again, imagine if you were to start having to try and calculate how much we have to back off this edge for, and you have to start trying to restrict how much you're doing. So it's a really nice function that you can back off there and work that automatically. So again, that's what we've got in here. So the eagle-eyed people amongst you will say, why haven't I done what I did before? Why haven't I gone into here and gone feed height from, and then just disable that? So again, gives me that really nice, quick, rapid down, feed move here and here, cutting move in the blue, and back up again. So if any of you are wondering why we've actually got these different colours, it's so you can see the difference, but also there's a little tip in Fusion which some of you might not know about. If I right click and edit, you notice here that that's a blue icon, the blue passes, and then you've also got yellow and green there. The hint here is that if you change things in the blue tab, it will change that. If you change things in the green and yellow tab, it will change that one. So I'm going to go on here and I'm going to actually put a little bit more linear leading distance. So I'm going to put 5 million just to make it big so you guys can see what I'm talking about. And you can see I've adjusted something in that tab and it's adjusted the other one. The same goes for most of the toolpaths we've got. We try and keep that theory going, that you've got blue and then you've got yellow and green, so that's the linking moves and the cutting moves. And hopefully anything you touch in that pass will affect that one, anything in the other one will affect the other one. I mean, there are some areas where that does cross over a little bit, but that's the general consensus that we try and keep going. Okay, so now I need to basically break all the rules I've just told you. So yes, I could put a smaller chamfer tool in to measure this. Let's just quickly see what we've got here. We've got an 8mm diameter hole there, and we're going to try and chamfer that with our 12mm diameter tool. Now I could just come down and spot it, so just come right down and spot that, but I don't want to be doing that. It's not very good for the tool. You can get lots of problems with chatter. I want to use it like a chamfer mill and go in, lead into the cut, do the cut round, and then lead back out again. So I'm going to go 2D chamfer, click on there, and I'm going to do nothing. I'm just going to hit OK and see what I get. So, got a warning. What have we got? Empty toolpath. The contour was not machined because the given lead parameters would cause a collision. Okay, let's have a quick look at what we've got going on here. So, let's edit this toolpath. Let's look at our linking. So what it's saying is it possibly can't fit that in there. So, let's whack this right down and see what we get now. Right, we've got something, but that is pretty much still going to be almost a spot. It's going to come down, it's going to do that. It is pretty much still going to spot that hole. It's not going to mill it properly. And that's because I now need to break all my rules I was telling you. We go back to that first look at the chamfer tools, and we look back at that sweet spot. Unfortunately, I'm not going to be able to get that. So what I need to do is bring that sweet spot down for this little hole, go down a little bit closer to the tip, and effectively make a smaller chamfer tool by doing that. So, that sweet spot sits at about the 7 diameter mark, so 7mm in diameter. I've got an 8mm hole. You can do the mathematics on that. So what I want to do is bring it down so it's more like a 3.5mm chamfer tool. So again, what I'm going to do on that is effectively go here, going into edit, and then I'm going to manually change this and put tip offset of, let's go for 1, let's go for 1.5, feeling generous today. And there we go, that's a lot nicer. This is probably going to plunge and catch on there. I do want to see actually what happens. So let's simulate it. Let's have a look. Again, I'm sure a much better machinist than me is going to know, but I tend to just use the simulation, have a look what's going to happen. I tend to know what I want, but don't know how to get there at times. So we are right on the cusp there of actually, there you go, we've plunged in and we've caught the edge of that chamfer tool, and I really don't want that because the speeds and feeds are going to be wrong. It's going to be plunging down in that Z angle. So you can just hopefully see there that on that plunge move, I'm just catching on. I could use these arrows and move it that way. Probably a bit more nicer for you to see. So I've got the plunge move, comes down, then got the lead in move there, and then I've got the whole chamfer move. So I want to try and change those lead-in parameters back to a little bit higher than what they were. So let's go for linear lead-in distance 1. I mean, if anyone doesn't use the tooltips, what on earth are you doing? We spend a lot of time getting these good, so please hover over, look at the tooltips, and hopefully they're going to give you a good idea of what they actually do on the product. That is going to change that linear lead-in distance on there as well. So I'm just going to click OK. And you can see that linear lead-in has just come out a little bit more. We've got there, so let's just simulate. Turn the model off again. And play. Let's have a quick look what happens now. Okay, cool, so let's pause it there. So we can see I've finished my plunge move there. I'll just probably flip around to the other side of the model for you. So you can see I haven't cut in during that plunge move. I'm going to cut in that lead in, and I'm going to do my chamfer cutting. Again, so it's not looking too bad. I'm not cutting right on the very tip. I'm not cutting as high up the tool as I'd want to, but I'm definitely not cutting right on the tip of that tool there. So I should still be at a decent surface speed on a nice strong portion of the tool, while still maintaining the ability to chamfer that hole. Because at the end of the day, I'd much rather have a not so efficient toolpath than have no toolpath. I'd rather have to run it a little bit slower and risk a little bit worse of a surface finish than have no chamfer there at all. So yeah, I mean, that's pretty much my main tips and tricks really on chamfering. So yeah, please answer us in the chat. Let us know if you've got any questions. Hit us up on the forum. We're always there. We're always on the forum, trying to answer as many questions as we can. If one of us doesn't answer it, I'm sure someone will. But I think a lot of us like to pride ourselves on. You go on the Autodesk Manufacture forum for Fusion 360, and pretty much page 1 is the last 24 hours. It's that active. So yeah. So a quick look. Let's look at all the toolpaths. If people haven't seen these new visibility icons and the fact that you can also hover over, it's some nice visibility stuff we've recently put in. So let's just, let's simulate the whole thing and see how we go. So I'll let you just bask in that glory for a minute of watching the chamfer tool run round. Lovely. Cool. We got anything pressing on the chat, Paolo, other than...
No, we've had a couple of questions. I've answered them in the chat, but I just wanted to make sure that everyone knows, if you've got any questions after the live stream ends, you can just pop it in the comments and I'll make sure to
Oh yeah, good point.
answer as
Yeah,
soon as I can.
yeah, we'll keep watching this on YouTube for a couple of days. So yeah, feel free to put the comments on the YouTube as well, and we'll jump on and answer them on there.
Yeah, just also I wanted to mention that if you've missed the first bit or the last bit and you want to watch it again, this is going to be on the Fusion 360 channel for everyone to watch at any time. Really, it's going to become just another video, so you can watch it anytime.
Yeah. Cool. I mean, with that, there's plenty more live streams coming up. We're going to try and do one as a team. Myself, Paolo, we've got some other people in our team. We're going to be trying to do them every Thursday at the same time. So yeah, please tune in for the next one. Put some comments on the channel, on this YouTube video of any live streams you'll want to see. We'll start getting a lot better at scheduling them a bit further in advance. We're only about a week at the moment, so yeah, chuck some comments on the YouTube video. But yeah, got some comments here about the tutorial is a little bit early for North America. Thankfully, you'll be able to watch this at your own leisure. 1 o'clock in the morning when you've got nothing else to do, you just want to listen to mine and Paolo's voice to send you to sleep, you can play this on repeat.
Yeah.
Cool.
Oh. Right. Thanks everyone.
Cheers everyone. Thanks for watching, and hopefully see you again soon. See you.